Good afternoon. How's everyone doing today? Good. There's a lot more people in here than I thought I would. How many people would actually consider themselves a beginner here? Raise your hand. Oh, awesome, good. So I think you're all gonna like this talk. My name's Phil Henderson. This is my friend and colleague, Ivan Porta. Today we're gonna be talking about Don't Panic, a beginner's guide to troubleshooting Kubernetes. And without further ado, Ivan's gonna start on the slides. I need everyone to kind of like knock on wood and hope my demo goes well. Otherwise, we're going to be really troubleshooting Kubernetes. I'm just hoping I'm not troubleshooting my Mac or the wonderful Wi-Fi brought to you by Render ATL, as it says on their Wi-Fi thing. So without further ado, Ivan, go ahead and start talking about how to begin.
OK. So this is just an example of what a microservice application looks like. We have multiple microservices. They can be written in different programming languages, like Rust, Go, Node.js. And we're talking to each other, and potentially even to database, S3, and more. They can also be maintained by different teams in the same organization. So you have team A, B, C, D, taking care of different microservices, each one implementing their metrics, tracing, circuit breaking, timeouts, and more.
How many of y'all are platform engineers here? Developers? How many of you are writing different languages without your organization? Or you have one? OK. So what Ivan's describing here is relevant to some of you.
So as you can imagine, there is a lot of reinventing the wheel, because we have multiple teams like implementing metrics, then we have to do the same thing across multiple microservices. And the problem is, sooner or later, something will go wrong. One microservice down the line will eventually fail, and that, if not handled properly using circuit breaking, timeouts, might actually create cascading failures. So you have multiple microservices failing, and you don't know why. You don't know which one is the culprit, and you find yourself having to troubleshoot, checking the metrics, checking the logs of them to try to find the culprit as soon as possible. The problem, though, is we're talking just on one cluster right now, and the Kubernetes is evolving. More and more organizations are using multi-cluster architectures. So we are not just talking about troubleshooting one cluster. We are talking about troubleshooting multiple microservices that span across multiple clusters. As you can imagine, that will increase the complexity, will increase the time to actually troubleshoot the issue, and mission-critical application that becomes very expensive.
Who all here is worrying about multi-cluster and having to worry about more than just one cluster? Or are you all lucky enough to have just one production cluster you have to worry about? Who's worrying about just their one production cluster? OK. Who has more than 2 clusters? More than 3? 4? See, a lot of those hands still stay up. Do you have eyes on all those clusters? I hope so.
This is a report from Splunk. As you can see, it's not just about loss in revenue, but there are a lot of indirect costs about downtime. You can see the relationship with customers, the relationship with partners that are going to be damaged by this downtime, SLAP penalties, regulatory fines, and more. All these small things adds up to what is the financial impact of downtime. So it's become very important to solve the issue as fast as possible. And this is where a service mesh comes in. Linkerd service mesh is an infrastructure layer that deals for the service-to-service communication, deploying proxies alongside the application. So the application doesn't know anything about the proxy. We'll just send a request, that bound request. The proxy that sits in front of the application will change the route tables of the pod. So all the inbound and outbound requests go through the proxy. So if you look at the previous diagram, now we have all the microservices that are still talking to each other, but in front sits the proxy, which brings its own logic. So you don't have to implement load balancing, retries, circuit breaking. The proxy will take care of that for you. So if you look at what the developers had to do before, they had to do everything. Developing the code, metrics, log, tracing, retries, traffic control, rate limiting, everything, which took away a big chunk of their time. By using a service mesh, you delegate almost all of these aspects to the proxy, so we can focus on the business logic of the application. So how does Linkerd works? Linkerd has a two-layer architecture. So you have a data plane and a control plane. The control plane is basically the brain of the mesh. It takes care of service discovery, certificate management, pushing the configuration to the proxy, injecting the proxy in new workloads, and then you have the data plane. The data plane are more like the muscles of the service mesh. They take care of enforcing these policies, like applying load balancing, and then encrypting, most important, encrypting the traffic so that everything is not in plain text. In terms of metrics, the proxy will expose both layer 4 and layer 7 metrics. You can see, for example, for layer 4, TCP connection open, connection close, read, write bytes. For the layer 7, you're going to be able to access the amount of requests, responses, most importantly, the latency, so you can monitor the performances of your application. And then, in case we have multiple backends, you can actually see the request of each one of these backends using, for example, HTTP or gRPC. At the bottom, you can see control. That's more for traffic management, because you can actually see the DNS resolutions. You can see, for example, the endpoints that are kept into account by the proxy during the load balancing. So you have a clear view of everything that is happening using metrics. So still about metrics, there are some which are very important for actually performances, which we call them golden metrics. They're like the success rate, the traffic, and the request per second, and the latencies. In terms of latencies, there are some important, like the P90, the 90 percentile, 95, 99, the 50. In terms of traffic, the proxy will expose metrics related to the request per seconds, as we saw earlier, and then the success rate. Since we are considering gRPC and HTTP, we're going to see the status code for 200 and 500, and then the code for the gRPC as well. All of these metrics are exposed in Prometheus format, so you can use OpenTelemetry collector to scrape all these metrics and render them, for example, in Datadog, OpenSearch, or any other monitoring tool that you're actually using. Telemetry-wise, the proxy, you don't have to do anything. Basically, the proxy, when there is an inbound request, will actually monitor for the header. And if it's a tracing header, will automatically expose its own spam. So you can collect them and then render them, for example, in Jaeger or Splunk. So you can actually see all the properties of the span emitted by the proxy, but also see all the general flow of what's happening. If, in case you want, you can also add additional properties to the span of the proxy using environment variables. You might say, OK, that's perfect. I have all these metrics, all these traces, but it means that I have something more to maintain, which means more work for me. Well, we have a CLI that will actually check multiple key components of the mesh. Some of them are, for example, the certificates, because to apply MTLS, you need certificates to encrypt the communication. So when you run, for example, the Linkerd check, which is a single command, we'll check the validity, the expiration date of these certificates for you. We'll also check the webhooks, because in order to inject the new proxies, we need to communicate with the Kubernetes API. And that's also another certificate we need to make sure that it's still valid. Then you have the control plane and data plane version. Well, actually, that's not an error. It's more like a warning telling you, listen, there is another new version that might contain new bug fixes and new enhancement for you. So it's more like let you know that it's not the latest version. And then in case you are using extensions like Linkerd CLI, Linkerd multi-cluster, we'll perform other automatically additional checks based on the extension that you're using. Another thing that the Linkerd CLI brings to the table is the diagnostic subcommand. Using this subcommand, you can actually, first of all, you can check the endpoints and the policies and service profiles that are affecting a particular workload or service. So you can see the endpoints that are considered in a specific moment in time by the proxy. You can see the policies, like, for example, that are managing the outbound and inbound traffic, like, for example, HTTP routes. And then the metrics. You don't have to use port forwarding and then currying a specific endpoints to access the metrics. You can just simply use the Linkerd CLI, and that will do that for you. Now, how can you install Linkerd? There are 3 different ways, depending on actually your flow. You can use Helm charts. You can use the Linkerd CLI. But also, you can use the Linkerd operator. The operator, basically, all you have to do is defining the values and the version that you want to be installed in your cluster. Basically, you are defining the desired state. The operator will then work in cycles and make sure that the desired state matches the current state, downloading the related Helm charts, applying the configuration, and then installing the Helm charts for you in the cluster. Now, about AI, as you can imagine, there are tons of talks about AI, and Linkerd is not staying, is doing that as well. So we are introducing MCP support. If you are interested, you can scan this QR code to book a demo. It's not officially released yet, so it's more like an internal beta test. So if you want to see more about that, you can book a meeting, and we are going to show everything that we are working on. Now I'm going to leave the stage to Phil, and this is the architecture of the demo. And if you have any questions, we can answer it later.
All right, this is the fun part. We get to break stuff. So you said you're all a lot of noobs, so I'll give you kind of a lowdown of the pieces we're going to be using here. Who here is familiar with the Grafana stack? OK, good. So there's going to be a lot of pieces we're using there. We're going to be using Grafana, Loki for logging, Tempo for traces, and Pyroscope for profiling. We won't get to those other 2. When we talk about observability and troubleshooting, we talk about metrics, logs, traces, and getting profiles and that gets a little deep into stuff. Since this is beginner, I'm going to focus mostly on metrics and logging, because you get a lot of information from those 2 things. And you'll be surprised how many organizations don't keep an eye on those things. And as Ivan was alluding to, is a lot of this stuff can be easily obtained powered by Linkerd, having a service mesh on top of your services. So for this demo, we're going to be using EmojiVoto. It's a little test app that we've had out there forever. We have a couple of good test apps called Faces, and we'll bring that up as well. But EmojiVoto is designed to break. It has some problems in it, throws some 500s, and we're going to go find out how to look at that. And to make this demo fun, if you have questions during it, come up now. Don't wait till the end. Make this a little bit more interactive. Otherwise, it's just me up here preaching. I'd rather have a conversation than just me preaching Kubernetes. So there's my 2 cents. That, or I'm going to pick somebody from the back of the crowd to ask questions. So don't think you got safe back there. Front row, you're not safe either. All right, so some of y'all said you're familiar with Grafana. For those who aren't, Grafana is a way to display metrics, logs, traces, and profiling for your applications. You can easily install it with Kubernetes stack. It's a community-maintained Helm charts that pretty much have the whole stack in there. Grafana, Prometheus. You can add Loki. I think I did my Loki stuff a little bit separately. But I have pretty much a full Grafana stack here that's going to give us all the insights. As I was alluding to earlier, we have a test app called EmojiVoto. You can go through and vote for your favorite emojis. I always like to find the, where is the rabbit? I don't know why I find the rabbit, but there. Little Bugs Bunny. Then let's see, I'm always a fan of donuts. Let's go get a donut. Oh, well, okay, something's wrong there. I don't know why our donut's not working. So let's go and start digging into our metrics. So again, Grafana has 4 major things you can do. You can graph your metrics, you can look at your logs, you can look at your traces like I've talked about, and your profiles. For now, we're going to start digging into some dashboards. Linkerd has some generic dashboards. Well, we did until we may be troubleshooting Grafana today instead of our application. Which is always fun when you do demos live. Let's see if any of my metrics are coming up. Let's go to core DNS. Okay, so we are getting metrics. So this tells me a few pieces of my technology are working. My Alloy is working, so we're using Grafana Alloy to collect all of our metrics, our logging. Is kind of the go-to now. There was a Grafana agent back in the day, if anyone's familiar with that, but Alloy is a new kid on the block. It handles all the OTel, grabbing metrics, logs, traces, profiling, and sending it to a centralized location, or many locations. It's pretty versatile. So I can tell that's working. I can tell my Prometheus is working, and I know my Grafana is working. Don't know why I'm not seeing my other dashboards, though. But that's okay. Not logged in. Yeah, I have this set up to be pretty much no auth and kind of like the very unsecure way. This is not how you do it in production. This is how I hope you're not doing it in production. I won't say people aren't out there doing that, but so since I can't dig into my Linkerd metrics at the time because my dashboards are gone, the demo is going great so far. We're going to just dig into some generic Kubernetes stuff, right? This is why you're here. Some of y'all may have never even looked at some of these metrics. Some of the most important things to keep an eye on in your Kubernetes cluster is core DNS. How often have we heard the joke, it's always DNS? Who remembers a few Mondays ago during a major cloud provider's incident? Does anyone remember what that problem was? It was DNS, yeah. So it's always good to keep an eye on core DNS. It's the main DNS component in your clusters. Most people install it. It has 2 pods running in a cluster most of the time, and that's it. Nobody touches it. Nobody even thinks of tuning it. Again, you should probably have some eyes on this, know how many requests are going to core DNS, how many are being successful. You may need to tune your core DNS. Another important component of Kubernetes is etcd. I don't have any etcd statistics, which is wah-wah, but that's okay. Let's see, what else do we have here? What are y'all interested in? How about you? What kind of statistics do you want to see in Grafana? I said I would pick on someone if no one came up here and asked questions, so. You don't use Grafana, what are you using for observability, if I may ask? Okay, he says he's using CloudWatch. Who here has eyes on their stack? What are you using? I'm asking questions now, so I'm gonna pick on someone else. She said Grafana and Kibana. So you're using kind of the, so isn't that more of Elasticsearch's thing, Kibana? So okay, a nice mishbags of things. Any problem with Loki? Loki's nice. Let me show you this one. Let's see if it works. I don't think it's gonna work. Sorry, fam. We're gonna go back to troubleshooting things live. And I will blame the Wi-Fi. DNS, yeah. I'd rather blame something I can't control, which DNS, I could control the Wi-Fi. That's in someone's hands right now. I don't know if y'all heard the announcement. Somebody was trying to blame personal hotspots on the Wi-Fi being bad. For anyone who knows Wi-Fi, that's not a thing, so just ignore that. Okay, we got time. Oh, okay. All right, so I have just a simple script here that sets up my demo. I'm just gonna have it reinstall everything. I'm actually not having it reinstall anyone. Who here is using Helm in their environments? I would hopefully think everybody. All right, so what I'm doing is a Helm -A update. So -I update, excuse me, got my val wrong. So we're saying, hey, whatever's over there, upgrade it. It should be the same. It should be idempotent, if you're aware of that word and what it means in automation. That's always the goal with automation, is making it idempotent. Whatever you can run, it's in the same state, doesn't change what it needs to be. I'm hoping that's the case today. And if there are any questions yet, there's a nice mic here, and you don't have to just hear me talking. I know somebody has a question.
I want to see tracing. We don't do a lot of tracing. We're typically monitoring metrics and trying to trigger alerts in dashboards, but tracing is certainly an area.
And you're not doing tracing today? Okay.
No.
And what's the pain point there? Is it just because it's hard to get started?
Yeah, it's hard to get started.
Okay. With Linkerd, we have some OTel stuff right out of the box. So you pretty much define your open telemetry thing and start sending traces there, like Ivan was showing. I don't have that set up today and nothing's working, so I would love to show you. Ivan and I are going to be at the Linkerd project booth after this. I promise I'll get my demos working. If you want an appetite for destruction and come by, we'll put my money where its mouth is and see if it happens. Even this is failing. So let's go try it one more time, fam. Dashboards. Womp womp. All right. Well, that's disappointing. It's disappointing there was no questions either. So, well, that's all I have at this moment, if there's no questions. And my demo is failing, so I apologize. You can watch me debug it up here for, I have 10 minutes. So,
I got a question for you.
perfect.
Real world scenario.
Oh, thank you, MC. More for the recording than anything. You can hear yourself on YouTube later.
I don't want to do that now.
No, that's fine. No, do it.
So talking about debugging, I don't know if this is a use case. To be honest with you, I can't think of a situation where I would want to use a service mesh for this. But this is a real world use case. Customer opens up a support case, and they're trying to understand why their application isn't working, right? I hit the URL yesterday and it works. Hit the URL today, it doesn't work. And then they started going backwards, all right? So they went from the URL to the service. They checked the service and the route, and then to the service. They looked at the label. Okay, app equals whatever. Okay, we go look at the pods. There's no pods running. Well, why isn't the pod scheduled? Well, we're in container creating, and then we go and we end up determining that developer somewhere messed up the node selector, and they put it to the wrong node, and then the node's missing a GPU, and since the GPU isn't present on this particular node, pod can't come online, and it's a cascading failure, right? If pod had come online on a node with an H100, the pod comes up, and then it goes back up the chain, and everything works. How can we debug that issue going from the top down, right? How would that be a good use case scenario to help, instead of you're going step by step to quickly identify what the real issue is, that it was a fat-fingered somewhere in the Argo CD, and they got deployed, and now my application, the entire thing is down simply because my node selector was incorrect.
I'll tell you my opinion and take. So there's a project out there called Kyverno. Anyone heard of it? Maybe, yes. Enforces policies, right? Saying, hey, if you don't have the correct things defined, we're just not going to do it, which would still create a pain point, but sometimes it's more or less you have to start training people to cross their T's and dot their I's. And you mentioned Argo CD. My question would be did someone not review that merge request before it went to Argo? Or it's it should have some type of, there's a lot of AI talk around here, but at some point we have to put actual intelligence onto stuff, right? So if there was a commit that had a diff, and you had a reviewer looking at it saying, you have this node selector on here, and that's not even a node we have, guy, what are you doing? That would kind of save you. And that's kind of the pattern we see in a lot of production environments of hey, having those checks and balances, having something, a policy engine, enforcing things hey, if you don't have this defined or you don't have the correct one defined, to kick it back to, a developer group or an application group. The tough thing that I run and with a lot of our customers I work with in big enterprise environments is the difference between having platform teams and application teams, and there's a big knowledge gap in where the platform owners don't know or don't need to understand the application. And the application teams believe they don't need to understand the platform. And this creates a divide that I see every day, every week, and there's no good answer to it right now besides just being a little bit better, learning more, being open to change, and having processes in place, good processes in place, not just processes for processes. And that's always my advice to people. It's we can't fix everything, but if you have good processes in place, we can catch most of those failures before they happen. And to answer your question, a service mesh can help with that. You start seeing failures down to a specific service instead of having to go from, okay, where is all this stuff? You just say, well, that thing's not even scheduled. It's just failing. We're just getting 100% success failure here, or failure, not success failure. But you know what I'm saying. Hope that answers your question. Yes, sir. Got another one.
How could you use this to find out if the control plane was overloaded?
The Kubernetes control plane or our Linkerd control plane?
the control plane for the pods in the MTLS?
So let me go to my Linkerd dashboards right here in Grafana. So we have dashboards that come with it as well. And it's like a good Linkerd health page of like, hey, are you doing the right things? Are you running in high availability? What are the resource request usage of the components? And then like Ivan was showing in the slides, there's this our Linkerd CLI command. We can do Linkerd check, and it goes through does a bunch of verifications of do you have this set? Is your certificates healthy? Are you in HA mode? Are you in a production setup pretty much?
Right. The situation we had last week was there was 20 namespaces. One of the namespaces was spawning pods like it was new. And it overloaded the control plane and had an HP.
Linkerd control plane?
No, it wasn't. It was an Istio control plane.
Oh, okay. I cannot speak too much for that one. I'm
it-
a bit biased,
Really?
but yeah. I have familiar, I used both Istio, Kuma, and Linkerd all in large production environments for a small cable company called Spectrum long ago, so I've had to deal with all flavors of it in production. I obviously picked a side for a reason, so that would be my 2 cents.
Okay, other than the poor choice, we overloaded it. It got up to the 15 pods, wasn't able to service out the routes to the new pods. They timed out at startup, and it just kept on cascading, and it took the service team like 8 hours to get it fixed.
Yeah, if Istio's control plane is anything like the Linkerd one, it probably has similarities. Anytime you have like a large rollout upscale of stuff, these control planes need to know about every endpoint, every service within a cluster. So it's not like just an Istio problem or Linkerd problem. Like we have to, if it has memory limits set, at some point when it's collecting all this information, you're going to fill up that memory. If you have low limits set, you hit that limit, it's going to ohm out, right? So that's like when we have conversations with people on like, how are you sizing stuff? How are you sizing your control plane? How is your cluster act? How many nodes does it have? Does it go from 100 pods to 2,000 pods? Like, what does that SKU look like? You have a question? You can come over here too if it's easier. I don't want to like this gentleman to like run himself ragged. He's gonna get a marathon in. Watch my time. I have 4 minutes.
Okay. It's
Someone
gonna be
get ready for another question. I want one more before I go.
And it's Linkerd stable for sidecarless features.
Can you say that again?
Sidecarless.
It is not sidecarless. We take a very opinionated approach on that for many reasons, and I would love to get into in depth about it. It's depends on security footprint, single points of failures, and there's just a lot of different opinions on it. William Morgan, our CEO at Buoyant, did a talk on the sidecarless battle. So there's a past KubeCon talk that's very informative on why we chose having a sidecar versus using more of what the new kid on the block's using. And I have competitor analysis of that too. I'd love to show it at the Linkerd booth. Yeah, my last question. Perfect. Thank you, sir.
Thanks. I have to deal with on-premises Kubernetes quite a bit for my position and network time. I'm curious about the host OS and network time discrepancies and what I can expect for failure modes at maybe container, pod, deployment, and, Linkerd.
Yeah.
How can I think about those different levels?
Are you having a lot of NTP skew on your host systems?
Well, I'm just curious, what should I expect for failure modes if I have time skew?
Time skew, yeah. One of
'cause I'm
them is
on-prem.
certainly your certificate validity, right? So, we set a date of your certificate is valid from this time to this time. Depending on how bad your time skew is, I've had Raspberry Pi clusters I'm testing stuff on, they come up, have no internet, and they think they're 1970. Well, I created a certificate for 2025. It's going to go, it's expired, right? So having good NTP servers, they always say DNS is the problem. Well, I battled an NTP server in my own on-prem home lab for a long time before I realized this thing's 10 minutes behind. I'm always getting my certificate out of date. So it just, it's a real problem on-prem solutions have, right? You have to find good time servers, and you can't just rely on the upstream NTP pool ones, because if you're in an air-gapped environment, sensitive data environment, you don't want to reach out to the world, right? So, and there's a lot more environments that are on-prem like that, and maybe yours is air-gapped and hey, we can't rely on global NTP servers for stuff. So that's kind of the failure prospect there. Is like mostly with like Linkerd, it's going to be in the certificate validity. Any other questions? I have less than 60 seconds. All right, everyone. Oh, wait, give me one more. All right, perfect.
Thank you. So I've been dealing with a lot of Kubernetes problems, troubleshooting lately, and I'm an application developer. I don't have permissions to run everything I want or access to all the namespaces. One of them was like, oh, persistent volume does not mount, and that turned out to be a core DNS issue. And the other things, things like no space left, and that turns out to be the Docker layer images are filling up. What would you recommend? And just by looking at the, seeing that there's a Linkerd dashboard and etcd, what would you recommend to the application developers to keep an eye out to get more visibility? Because we don't have like permissions to access to everything we want, or maybe we can go to the platform engineering and request some of the dashboards, right? Like that would give us insight, if that makes sense.
Yeah, and my comment there is like, is your platform engineer here? I would like a word with them because they should be providing you this stuff, right? And for the platform engineers here, here's a real world developer having problems, and the platform engineering team isn't getting the things they need to be successful. So it's, I just talked about that gap, right, between application teams and platform engineering teams. Like, I don't know the answer, but there needs to be like a Venn diagram, even if it's a little sliver of like, hey, if you're not giving something to your developers, you need to ask yourself why. If they're asking for it, they need it, right? You need to have these insights because you just want to get your code checked in, done, tested, and know you can go on to the next problem you got to solve. The answer is having good dashboards, right? You shouldn't need permission into your Kubernetes clusters to like have to go kubectl every little thing in the world. You should have good, what I call nuclear dashboards for like when something's about to, explode, you're seeing a flashing light and you can dial into it then. Oh, this is my problem, this is how I need to fix it. So I know that's like probably not the answer you want to hear is like, hey, we need your platform engineers to be a little bit more up to snuff, right, and have everything you need to be successful. That's my answer. So if they're here, let me know. I'll gladly have a conversation with them. I think I'm getting flagged off, so I apologize for going over by 1 minute, but thank you for asking all the questions. For those, if you have questions, come to the Linkerd project booth.